Hello, good morning. My name is Blanca Garcia, and I'm a software engineer at the BBC.
And I'm Neil Crofts. I'm also a software engineer at the BBC, colleague of Blanca's, and I'm also part of the BBC's Digital Security Champion Network.
Today, our motivation for our talk was last year I was an attendee at DevOps, and there was a talk about serverless where the speaker was saying, well, this is a very interesting technology, but I don't see it quite ready for the real world. And at that point, we had been deploying on our live services serverless components for a few months, and I was thinking, wait, but it's kind of working for us. And that since then, I had been kind of talking. Me and Neil worked together in the same team. We discuss things and do lots of pairing. So we've been kind of discussing since then what could we show. And today we're going to show you the experience that we had where we re-architected some parts of our big data pipelines, and some of the components we kind of swapped them out for serverless. And we're going to present that to you as 7 key recipes. It's going to be high-level talk about concepts, but we hope you have some interesting and applicable takeaways from it. Before I start, I'm going to do a short introduction about the BBC. Okay, I didn't grow up in the UK, I grew up in Spain, so I was exposed mostly to BBC News and radio. And I wasn't aware that actually the BBC is a public broadcaster, and our funding comes mainly from UK license fee payers. So yeah, we have a big focus in the UK. So we are not driven by money, but more by are we reaching all the different communities and groups that make up the UK nations and regions. So for us, it's very important to measure our reach within the UK and also apply our mission principles so that everyone can find something that they enjoy and they appreciate from the BBC. This is a number of BBC services. Okay, so BBC News and a myriad of radio services are available, and that's kind of available worldwide. But within the UK, we are important in BBC Sport. We do a lot of retransmissions. We have a TV catch-up service that is very popular called iPlayer. CBBC is a news channel for children, and we also have a very popular weather app. And BBC Introducing is actually a very interesting service. It's meant to help up-and-coming artists to promote their content and eventually kind of get their names out there. So yeah, this is a very kind of brief thing about the BBC. Where do we fit within the BBC? So we are part of the personalization services. So I show you some very high-level numbers. What we've been going towards having more granular numbers about what is our kind of audience, our customers made up of. Because we need, in order to get them things that they enjoy, we need to understand more on a granular level, okay? And we're also using that data to drive decisions about where do we need to be spending our efforts to create content and also to create services, okay? So it's also helping us out, make better use of the limited money that we have. Okay, and ultimately, this helps us answer the question as in what does our audience want?
Okay, all right. Okay, so Blanca's given you sort of a bit of very high-level background about the organisation and sort of what we do within the organisation. Just to expand on that, there's a couple of...
You've
done the wrong button there. Oops. Okay.
Go back, yeah.
Oops. Play. That's the one. There's a couple of important questions that we can address, or that we need to address first. First of which is, why are we doing this? Now, none of us in a room like this can have avoided recently the various scandals about data abuse, and so the BBC really can't avoid sort of discussing this. And even though we're software engineers, we need to really be aware of why we're actually asking audience members to share data with us. And so we asked around a lot with the audience, the people who sort of interact with our audiences and deal with the data privacy policies at the BBC, and they referred us to the BBC Privacy Promise, which can really be summarised in two sort of separate parts. Firstly, what do you as an individual get by sharing your data with an organisation like the BBC? And that's actually fairly straightforward. It's a fairly straightforward relationship. You share some data with us, and we can therefore learn a bit about you, about what you like, and we can help deliver to you some more compelling content that is more to your liking. So you basically get more out of the BBC by sharing that data with us. But then there's the other side of it, which is what does the organisation get out of it? There's always something that an organisation gets out of it. And in this case, it's part of the BBC's remit to be able to give everybody across, not just you as an individual, but absolutely everybody across all the different diverse groups. So by learning about individuals, we can actually also understand that everybody, not just a few individuals and a few specialist groups, are actually getting enough information. And just for the avoidance of doubt, I'm going to paraphrase an old employee of ours, whose username I think probably would be something like Orwell1984. Basically, Big Brother is most definitely not watching you when it comes to BBC's public service. We're definitely not trying to infer from you your political views. We're not trying to sell that on to try and rig the next general election. We're not trying to... I believe it's been done, allegedly, not by us. And we're definitely, public service organisation, we're definitely not selling your data to people to flog you stuff that you didn't even realise you needed. Okay. So, if there was such a thing as an acceptability scale on personalisation, then BBC's definitely wants to be rubbing shoulders with Doctor Who rather than conspiring with the Daleks to take over the world. Okay. Okay, so the second question then is, why are we doing this? Now, yeah, if you hadn't been at DevRocks, you're probably aware that that is exactly the same question. But this time I'm asking it from a technical perspective. So why are we doing this? Why are we migrating towards a newer serverless-based solution? And I'll let you into a secret. The first version of our software wasn't as great as we thought it might have been. Now, I don't know, that's a bit of a shock across the software industry. But anyway, rather than us moaning about what went wrong, I'd really want to focus about how we learnt what our real requirement is, rather than the one that people who didn't have to do the work thought it was. Really, we wanted any solution to be a lot more testable than the first version was. With that, we wanted reliability. I want to be able to sleep at night. I don't want to come in the next day thinking, oh no, something's broken. We also had a lot of scalability challenges that were coming towards us. I don't know if you were aware, but last year, I think it was March, May, was it March or May? It became mandatory to sign into services such as iPlayer, and that was going to bring a significant uplift to the amount of data that we would be dealing with. We're a public service company. We need to be very careful and mindful about spending people's money. So we wanted a solution that was going to scale with us and also meet our cost requirements. And from a technical point of view as well, we wanted to move away from sort of overnight batch processing to be a much more near real-time organisation. And of course, we have got an existing solution in the market, or in our internal market, and as such, continuity is really important for us. But to be honest, above all, we just want it to be simple. Okay, and fortunately, we work in an industry where traditional ways of doing things are constantly changing. I think I'm the second person to reference Heraclitus this talk. I think one of the keynote speakers mentioned it, so I think we're in good company there. And also Babbage, which was also referenced by another one of the keynote speakers. But basically, if you don't like the current technology, wait a little while and something new and more compelling comes along. And we think serverless actually has been quite a good match to our big data problems and our challenges. And sometimes, you just need to learn to let go of your old solutions and actually just get on and try new stuff. So, without much more ado, let's get on with the first of our recipes. And that first one, which I think is fairly appropriate for an architecture track at a conference, is architecture. Okay, so yeah, in order to understand how and why we were migrating to serverless, let's have a quick look at what our original architecture looked like. We have here a bunch of data processing pipelines, and they all have roughly the same sort of shape and form. First part is that data is ingested from either an internal BBC service or from external third-party services which manage data for us. That data is then enriched. Now, if you're not familiar with big data and data enrichment, essentially that means taking a piece of raw data and enhancing it using lookup tables that add value to that bit of data, extra insight, so that you don't have to calculate it every time. And then anyway, that data then gets dumped into essentially a large distributed data store filing system. And then finally, that gets pushed into a data warehouse system. So where was this complexity? Where were the major issues that we were encountering? Effectively in the blue section there, the map reduce enrichment. We were using absolutely, at the time, the right sort of technology stacks, using MapReduce to solve our problems. But if you're not familiar with MapReduce, it can be quite complex to get your head around. And here's a very, very high-level overview of what it's about. Essentially, you take a large amount of data and you distribute it across a potentially very large cluster of data. And that data then gets munged around and enriched before being dumped out to the output, in our case, a big data lake. But, as I say, it's not for the faint-hearted. And as we learnt our new requirement, and as technologies evolved, we found that we were able to start replacing the enrichment phases with a serverless approach. So how does that become simpler? Okay, well, what we do now, instead of distributing the data across a large cluster, we actually take that data and we split it up into small, manageable micro batches of data of just a few thousand records. And then every time a serverless, every time a piece of data arrives, a serverless function is invoked, which just simply loops through that data, processes it, enriches it, dumps it out. And that, to me, is fairly simple compared with the opaque complexity of MapReduce. And the scalability comes just by the fact that if multiple batches arrive at the same time, another serverless function just happens. You don't need to do anything. The platform takes care of itself. Okay. The other thing to mention that was important with our architecture was this notion of blue-green deployment. We needed absolute continuity. We couldn't afford for our data to go down or to be incorrect when we switched over. So we were able to run, with this approach, essentially a blue-green style deployment, whereby we ran in parallel both the MapReduce and serverless solutions for some period of time before, and then our data analysts sort of got in there and actually were able to do a really detailed study to make sure that it was like for like, good quality replacement, before being able to switch that off and start reaping the full benefit of serverless. So our first takeaway then is that through the use of serverless, essentially we've been able to take quite a considerable chunk of complexity out of our systems. We made a much more less opaque, much more transparent, easily testable service. And as a consequence of that, the blue-green has been essential for us in actually being able to sort of deliver that service without any break in service. Okay, so next recipe is all about scalability, and I've hinted about scalability earlier, but to understand the sorts of issues that we've got as an organisation, you need to understand the concept of a big news day. Now, for us, big news days can be things that are very predictable, like general elections or various live music events that occur, or other events, and even, as is going to happen in a couple of weeks' time, someone who obviously has no idea about the effect of scalability, has decided to plan both the FA Cup final and the royal wedding on the same day. Although fortunately they've staggered the kickoff times. Yeah. Okay. But as well as predictable stuff, we also have the obvious unpredictable things. You've just got to look around this nasty world. There's obviously lots of man-made and natural disasters that can occur. But even sort of mundane things like the weather can have quite a significant impact on what we actually do and the amount of data that comes through. So the recent beast from the east, was it? It came along in February-March time. We saw over a 50% increase in the traffic coming through to our system. And that's just our part of the system. So imagine across the entire BBC, it was quite significant, just because of a bit of bad weather. And just as a bit of a wicked exercise, we thought, well, what would be really unpredictable? And I thought, well, the best one I came up with, what would happen if England won the World Cup? Now, for me, that's quite implausible. Blanca is probably a bit more used to her national team winning the World Cup, but anyway, yeah, okay. So, as well as big news days and that sort of habitual background news, we've also got to deal with fairly significant variations in traffic during the day. We're primarily UK-based, and we do have a worldwide presence as well, but primarily UK-based. And this is just a fairly abstract graph of one of the activity on one of our services. I haven't got a scale on the side, apologies for that, but basically in the morning, you're ranging there from a few tens or hundreds of transactions, records per second, through to the evening schedule when people start piling onto iPlayer and catching up with things like EastEnders or whatever, and it's you're getting into tens of thousands of transactions per second there. So it's not trivial. Now, serverless, it's fairly easy to imagine that with serverless, the amount of savings that you can make is proportional to the amount of traffic that you actually receive, and indeed that is pretty much the case. But we found in practice that for these sorts of problems, if you just chuck a serverless function at every record that you get, then you're not going to get the most optimal solution, and in fact it can be quite expensive. So instead, what we found is that we need to optimize our micro batch size. But again, it turns out that that's actually quite simple, and the rough rules of thumb that we've followed are that we try and keep down the number of parallel invocations to an absolute minimum, and we do that by trying to maximize the amount of work that each serverless function invocation does. Whereas bearing in mind that there are service limits of, for example, with Amazon's Lambda, you can only run a serverless function for 5 minutes before it dies. So, and we also need to take into consideration the near real-time requirements that we've got. So we want to be able to sort of come up with a batch size that works for a particular service, that minimizes the amount of time between the first message arriving and the last message actually making its way into the data lake. But it turns out it's actually fairly straightforward to do that. And as such, then all that sort of white conventional waste suddenly does disappear, and you start gaining the benefits. So yeah, scalable takeaways. Big news, massively important to the BBC. Has a big significant impact, and optimizing allows us to maximize our cost savings. Okay, there you go.
Thank you, Neil. So yeah, actually it's incredible how much people love the weather. It's something that I had to learn when I moved here. I'm originally from Spain. That's the joke about the World Cup. Everything comes to standstill in the country, so maybe you don't want that here. And yeah, another interesting thing, we're in the big data space, so for us, for example, the data breach that we talked about earlier was very important, and we didn't see a huge difference in the amount of traffic that we received. So on a maybe like UK-wide scale or global scale, that wasn't such a big thing for people. And yeah, how do we get to know these things? So I'm going to introduce observability. It's a term that has been very popular in the last few years. perhaps you're more familiar with monitoring. Okay, the main difference between the two being monitoring is you kind of come up with a set of metrics and alarms to let you know when things are going wrong. But most of the time, I find that people put these metrics in like big dashboards, and no one ever looks at them, and they only kind of check their emails, and if things are red, and someone walks by and say, "Hey, there's something red here. Anyone look at it?" Then you kind of take account. So we've developed a set of dashboards that tell us more things than just things going wrong. As Neil pointed out earlier, serverless has a number of limitations that you have to play around it. One of them being the timeout, another being the number of concurrent lambdas that you can run. So as part of this, I wanted to introduce Sherlock and Holmes, which talk a lot about, sometimes you're seeing things, but you're not quite thinking about why are they happening. And also the big news days concept kind of affects us a lot. So we kind of tie our current metrics to things that are actually happen. So we measure not only errors and performance, but also the quality of the service. And we have a normalized approach to our serverless components. This is actually a screenshot of part of one of our serverless dashboards, where you can see kind of the rate of messages that are coming in, okay, and the percentage of messages, and the number of invocation of functions per minute. As I said, each function is processing a microbatch. And the other key thing is the average iteration time. So the lambdas have a default retry of 2. I think I heard that in one of the talks yesterday. But apparently in the wild, they realized that it's actually more than 2. So think that if you go over the invocation time while you are processing your data, your lambda is not only going to timeout, but it's also going to retry. And this will not only delay your data being processed, but it could also incur extra costs for you. So to create these dashboards, we have followed methods for instrumenting services that have become quite popular. If you are familiar with the RAID approach, which means rate, errors, and duration, you can look that up. There's another one called use, which is utilization, saturation, and errors. And you can kind of begin driving your metrics using this. Also, the very important thing with metric is not only to look at them every day. We look at them as a team together every day, and we discuss when something is all of a sudden peaking, and we're trying to think like, well, why is that happening? And sometimes we've even realized that some metrics have stopped being useful because we just were not looking at it, and we've actually deleted them. And we've also introduced new metrics for things that we thought that we kept asking ourselves, that we were perhaps checking manually, and then we thought, hey, we have to automate this. So ultimately for us, we have to answer ourselves the question, what is normal? And it's very important for me as a developer to know what are the minimum and maximum boundaries that my application has to kind of run in. We do a lot of load testing. We have unit tests and all that sort of thing. But for me, it's been a game changer to know how my application is behaving in the real world, because you will never know for sure what your traffic patterns are going to be. Okay. Also, for us, our numbers are evolving over time. Okay. In the last 6 months, we've seen an increase of about 20% in the size of the data set that we get. When you are perhaps working in the millions kind of records a day, that's not a huge change, but we're kind of in the billions transactions per day. So 20%, it's about 200 million extra messages that we have to process. And this also helps us kind of know whether we are going towards kind of the limits of the technology that we have chosen. Okay. This is one of my favorite patisserie shows, okay, and this was one of the judges, and I wanted to show her with a ruler. So whenever the bakers produced the patisserie elements, she came up with a ruler, and people used to criticize her a lot because it was very harsh, but she knew what each one of them had to measure. And I kind of took that back into my day job, and I was like, I have to know what each one of my measurements are. Okay, it's very, very key for you. So this is her with the rulers there. And so the takeaways for observability, know your trends and understand where you're going towards. For us, it was a migration, so we kind of already knew what traffic patterns we had to match. But if you're developing a new service, put all those metrics in place, even while you are developing, okay, on your testing environments. And that way, by the time you go to production, those things are already there. They should not be an afterthought. Expect things to change over time, okay? And for us, it's very important to know why they're changing. So events, yeah, I'm actually on support during the wedding day and the FA Cup, and we'll see how that goes. Yeah, but at least I have a good set of dashboards that I would just have a look at, and yeah, I think it would probably be fine. Okay, ask me later. And also, be ruthless about what you're measuring. Okay, yeah, I said, when you go to serverless, you want to, well, or any technology, you want to have some confidence that your numbers are kind of adding up. And the metrics that I showed earlier are very kind of granular. We have those dashboards for each one of our serverless functions. Okay, but we also kind of develop an extra step, which is more like a global number. So we ingest data from different sources. And we call this step reconciliation. It's an independent cross-check, so we count how many messages we did receive previous day, how many messages did we process that day, and see if those things match. Okay, it sounds very simple, but it actually tells us a lot, because there may be small rates of errors that are showing, but when you look at them on a global scale, this could mean thousands of records that have not been pushed through your pipeline, and this could be affecting your systems downstream. So for us, it's very, very important in the big data space to add more numbers to our metrics. And this was actually came from conversations with people. How many messages do you process in a day? Well, this is our rate, but wait, let me do the calculations. Oh, wait, I can put it in a dashboard. So we just put it there. This is outside of serverless. Okay, I'm not going to go into too much detail, but say that it's kind of essentially a daily cron job. And we found out there were some extra challenges there, as in, well, you have to count billions of messages every day. How do you do that in a cost-effective way, and also as fast as you can? Because if it takes hours, it's just not very, you're not going to run it very fast. So we developed some scripts with Python, bits of Java, and they were like, well, actually, command line tools are the best thing to do this sort of thing. They are super performant, okay, and when you look at the man pages and all the options, they just do incredible things. So when you kind of use pipes to process output, it's incredible. So I have kind of fallen in love again with command line tools during these past few months, because they help us not only do these daily counts, but also when we have to do, let's say, simple data analysis or narrow big data sets, filter them out, things like that happen in the data space. Python seems to be the standard, but it's just not very fast. Okay, so I do all that with this set of tools that I have learned. So I kind of feel that I have more of a horses for courses approach, and I have diversified the number of tools that I can use as a developer to solve different problems. And yeah, I think that's quite neat. So takeaways for reconciliation in the big data space for us, is very important to have a top-level view of our system that is kind of a verification step. And yeah, the next thing is a bit of a touchy subject for some developers who don't like to write tests. How do you develop a serverless component? How do you test it and make sure that you can handle change and maintain it going forward? So I'm going to bring here the testing pyramid, which a lot of you may be familiar with. Okay. In our serverless components, we use AWS Lambda. Okay, and we also this part that we have been talking about is actually implemented using Java 8. Okay, we do not use a lot of third-party frameworks. I know that raises controversy. There's no Spring, no dependency injection, because to start with, each function does just mostly one thing. We keep them very, very simple. Also, there was a serverless talk yesterday about security, where it was actually mentioned that the more frameworks that you depend on, the less secure you could potentially be, because you need to kind of be aware of the vulnerabilities in third-party frameworks that we use. So it actually makes us more secure. And we've invested a lot of effort in the unit testing. Like Neil said earlier, the processing that we do in our serverless components is mostly data transformations. So we have tested each one of the transformations, things that we may be kind of transforming hundreds of different fields. So all the effort is in the unit testing, and we can run those tests really fast, and so we run them all the time, and that gives me a lot of confidence as a developer. Then we have less tests, our integration, which kind of test those different transformations put together. And the end-to-end in this case is, well, you're going to be deploying your function to the cloud, and your function will have a trigger. Okay, in our case, we trigger our functions from S3 files. So each one of our S3 files is actually one of those microbatches that Nick talked about. So we have just pretty much only a handful of tests that actually just test that that trigger is happening and that the output is being written to the location that we want. So yeah, this has helped us blue-green deployments, which Neil mentioned, and also we run all these tests continuously, so that in the end has made us faster in actually pushing changes to life. And yeah, it's something that is very powerful. Another thing we've learned through unit tests and actually pushing these data transformations to production is you should validate all your data, okay? Even internal teams, when they send you data, okay, you will always have conversations with them about what things are expected and what not, but in the end, they tend to let through things that you shouldn't be. So our things have broken in production because of this stuff, and our tests have helped us catch it. So yeah, what are the takeaways for testing? Well, they will help you manage change and release often. For me as a developer, have more confidence in what I've developed is doing what it's doing. And they will also help you debug through issues when things go wrong. And this brings me to a very interesting one, which is, well, your serverless function could fail, okay, and you may be losing data, so how do you reprocess things? So we thought when we did this change towards serverless that they was probably going to fail at some point, and we needed to have a process to identify errors and also pinpoint where the errors were. I think that if you have hundreds of messages per second, in a few minutes you could have a few million messages that have not been processing. And this could mean that as times go by, the panic level of the team increases because they feel that they will never be able to catch up. And yeah, this is not a good place to be. So yeah, we wanted to avoid needing a haystack process because with our batch processing pipelines that we used to have before, a lot of the times we found ourselves there. And narrowing down processing when you don't have something that is well tested and it's just not very fast, it's very, very hard and very time consuming. So we kind of, what we did there is we added unique identifiers to our messages, but these go cross teams. So from the source of where that event is coming from, there will be a unique identifier that will help us trace that message throughout the systems. And this is very important because when we detect an error, we actually flag that message. We take it out of the processing pipeline, so the serverless function will throw an alarm and will tell us there's been an error, and we know we have an error bucket in S3 where we will push those messages to, and there will be some kind of manual intervention to see why did this message fail. And having the unit tests and the integration tests that I said earlier, we can easily push that record through there and see what went wrong. We define two different kind of categories of errors in this case. Okay, we call them soft and hard. Okay, this is a screenshot of one of our dashboards. We never put anything red unless it's failing because then people will get really scared, especially our stakeholders. So orange for us means there's something out of the ordinary, unexpected. Let's have a look. Okay, and that's the conversation. So I took a screenshot one of the days we have, well, a few soft errors. What does that mean? They mean that we have unexpected data. An example of that, let's say, a user goes and watches something on iPlayer, and we receive an event that a user has begun catching up on this EastEnders episode, and this is a timestamp. Well, we began some time ago receiving timestamps for the year 1970. It's like, come on, some validation has just not happened naturally. I know it's a valid date, but for us, what it means is that the data analysis that happens on a data set could be skewed because of that. And yeah, we flag them as soft errors. They're just more unexpected things. And the reason why we flag them is that, well, data analysts and machine learning algorithms they do some data cleansing, but if you do them as earlier as you can, you actually save time in the end. So yeah, those are those type of errors. Hard errors are things that will fail and they will make something downstream actually explode. In our case, hard errors are our data warehouse cannot import a certain field because, let's say, it's too long. Okay, and we define those boundaries with the teams that send us the data. Again, I think this is the maximum size for this field, but in reality, they have sent data that is far longer than that. So we flag those, and we've kind of highlighted to other teams like, hey, there's some validation here you haven't done. Can you please do it? So dashboards helped us drive conversations without pointing fingers, just saying, this has happened, could you please have a look, and this is the record, and this is all the information for it. So it's been really, really good for us. Yeah, the reprocessing takeaways are, think about how would you manage errors if you need to replay the data. How would you do that? In our case, when the data comes out of our pipeline, then once we know what is wrong, and if we've had to deploy a bug fix, we've already done that release, then we just dropped the file again on the S3 bucket that the lambdas are triggered from, and it just gets reprocessed again. So it works really, really well with serverless. And
okay, thank you. Okay, right. Our last recipe of the day is security. Now, there's two things to note about this. Firstly, BBC 7 looks fairly plausible, doesn't actually exist. So the moral of that story is don't trust anybody. Second thing, this is recipe number 7. Stuck at the end. Don't. Instead, build security into the life cycle of your system. I know that's probably fairly obvious, but it's easier said than done. But this is especially important these days, especially when you're being charged with dealing with people's personally identifiable information, like we are, and obviously with the advent of GDPR. So it's incumbent on all of us to deal with not only sort of brute force, thuggish style attacks, but also the more subtle, sort of disconnected attacks whereby seemingly innocuous parts of your system can be weaponized into you. I kind of think of these as supergun attacks, if anyone remembers that story from a while back. If not, look it up. Okay. So how does security affect serverless, or serverless affect security? Funnily enough, we attended yesterday a talk by one of the other DevOps presenters purely about dedicated to serverless. And he actually made a number of these points in a lot more depth than we can possibly go into here. So definitely look that talk up. It was really good. But it can be kind of summarized by saying that one massive positive advantage of serverless approach is that it takes away a lot of the responsibility for security of your platform, which I think is pretty good. But alas, application security still definitely falls on our shoulders. But there are plenty of commercial and even open source tools that can be used to help guard against this. But it's a way more detailed topic than we can go into here. So please do reference yesterday's talk. Okay. But another thing to mention about security came out of our use of threat modeling. Now, I don't know if you're all familiar with the concept of threat modeling, but essentially think of it as essentially it's quite a detailed critique of your system and your services and the resources that your services use. And if you go through your system fairly systematically, looking at those limits, you should be able to not only identify the risks and then come up with, ideally, with mitigation strategies for those risks, but you should be able to start predicting not just how your system may fail, but also when your system might fail, which is really quite powerful. And again, there's a lot of detailed information available out there, and I'd thoroughly recommend you look at this. So, did we actually uncover anything that hasn't already been addressed by other people? Well, possibly. we came up with something which we've named the cross-pipeline dependency threads. Now, I refer you back to earlier when we showed you the very top-level architectural view of what we're doing. We've got a number of, in theory, logically separate data pipelines. Each one uses sort of separate resources, albeit all in the cloud. And it's very easy to fall into the trap that cloud providers provide you this infinite bucket of resources. But when you actually start probing the detail of it, you'll find that there are some kind of little things out there that you need to be aware of. And one of those, in the case that we were working with, was the fact that there's actually a global limit to the number of parallel serverless function invocations that you can get at once. Now, I know you can change this, but fundamentally, there's still a limit. What that means then is that if you actually start working all the way back up to the top of our stack, you could find that an attack on any single one of our upstream services could in fact cause a large number of invocations of our serverless functions and ultimately starve not just that pipeline but potentially all the other ones, which I don't think is good. So how do we mitigate? Well, turns out at the time it wasn't looking that great. There was just a couple of possibilities open to us. One, we could move every pipeline out into a separate account, which is a bit tedious because there's some kind of advantage of having it all in one single account. But also the other option was to go and look at our upstream services and try applying some throttling to those. But again, especially if you're not fully in control of that, it's not necessarily that easy to do so. So had a bit of a dilemma there. But during the time that we were developing this solution, along came a new feature in Amazon's Lambda, such that you can actually now apply an individual throttle per Lambda function. I believe they originally designed that to allow you to work with old legacy systems, but the same principle I think now applies really quite nicely for this sort of problem. So going back up through our recipes back to the observability, you note that we understand what normal is for each of our serverless functions. So based on that information, we can set appropriate limits and throttles for each of our serverless functions, thus hopefully mitigating the problem or the denial of service or the denial of wallet attacks as they referred to them yesterday, which I thought was quite good. Okay, so security takeaways. Yeah, build it in from day one if possible. App security is definitely in our remit, even though serverless sort of takes away some of the platform responsibility from us. Okay, and finally, yeah, threat modeling. It's a really useful exercise. If you're not doing it, I'd strongly recommend having a look at the information that's out there about it. Okay. Oh, yeah. And if you want to learn a little bit more about the cross-pipeline dependency problem, we actually did a blog article about that as well. So there's a little bit more information about that there out there on Medium. Okay. So that brings us towards our close down. If anyone is old enough to remember this, yeah, it's almost time to say goodbye. Yeah, together, Blanca and I, we've gone through our 7 recipes, sort of showing that the migration to serverless functions for our big data processing wasn't a folly, but it was actually a really powerful way of simplifying our architectures whilst meeting sort of our new scalability challenges. The observability, reconciliation and testing have all improved immeasurably because of, or should I say measurably, as a consequence. And the reprocessing, whilst we literally hate having to get involved in that, it's an incredibly important part of what we do, because things, no matter how hard we work, they will fail. And of course, security. Don't just tag it on at the end. Okay, so I'm going to try now and summarise the work that we've been doing over the last few years and what it all means. And I thought, again, I might just refer you to a quote from our ex-colleague, which I know is pushing it a bit, but our ex-colleague George Orwell once said that the best books are the ones that tell you what you know already. Now, going back to the BBC privacy promise, I hope this works two ways. Firstly, I hope today, as you, as individuals in our audience, have gained something from this. I hope you found at least one of our recipes familiar to you and applicable in what you do. But secondly, I sort of thought, well, how does this actually apply to the wider audience? Can I give you an example, one quintessentially BBC example? And I thought, yeah, let's go for it. Unashamed. Okay, after all of our work, we now know, rather than thought, that people who live in cottages or on farms love the Archers. Now, I don't want to trivialise everything, but that's definitely concrete information that we've gained, and a whole lot more. Okay.
So, thank you for coming today. If you have any questions, now is the time for them. If you have also any questions about how we work, then we're happy to share. One last thing I wanted to share. If you were at the keynote yesterday and you heard Mark saying about new speakers and them doing this kind of clinic to get some new people in, I was one of the people that went to that clinic and also got my talk. So if you think that you have a different thing to show or you would just like to share and you want to know what the process is like, I'm more than happy to walk you through what I went through and the people that kind of supported me in all of this. So yeah, thank you.